Okay, 8.6, choosing a factoring method. This section is just a summative of what you learned the entire chapter. So there's really no new information presented here. It's just that they throw all the different factoring techniques into one section. So I'm just gonna do some example problems for you from this section. The first one, let's see. The first one they're giving you, they're asking you, is it completely factored or not? So you're always looking, first of all, if you can take out a greatest common factor. So if they're giving something like 2x, and then they have x squared plus 4. This one is in fact completely factored. There's something called a difference of squares that when you have a perfect square here and a perfect square here and a subtraction sign in the middle, then you can take the square root. So you could take like, hang on. Say you had x squared minus 4. So for just a minute, ignore this. If this was a minus sign here, this being a perfect square and this being a perfect square, means you can take the square root of this plus the square root of this times the square root of this minus the square root of this. And that is another one of those rules that they mention in section 8.5, and it's just called a difference of squares. This problem, because this is an addition sign, it cannot be factored. So you have, yeah, factored. So you have this one is already completely done. If they gave you something like this, this problem is not completely factored because this one has a 2 that could be factored out. So you could divide 2 here and you'd be left with x plus 3. Now it is completely factored, but this 2 had to come out. A lot of the problems in this section are just going to ask you, hey, factor it completely. The first thing you always want to look for is if there's a greatest common factor. So negative 2x y squared plus 16xy minus 32x. So the directions for this problem are just factor. Where you start is, again, it's taking out that greatest common factor. Looking, is there anything in all 3 of these that I could just divide out? And there is. There's a 2, actually a negative 2, and an x. So I'm going to take negative 2x outside of these parentheses. And what I'm going to leave in here is just going to be y squared. This is going to be, because of careful, I took a negative out, so that's going to change that sign to a minus. And this is going to be an 8, because I divided it by a 2. I divided by an x, so that's a y. This, because I took the negative out, is now a positive. I divide that by 2. and I divided it by x, so the x is gone. So that was just factoring out that greatest term. Sometimes when you do that, you're done. That's all that can be done with the problem. You always want to check to make sure that this trinomial can't break down further. So because there's no term in front of this y squared, we are just going to look at this 16 and we're going to see, is there anything that that multiplies to be positive 16 but adds to be negative 8? And there is. There's negative 4 and negative 4. So we are going to factor this with a y here, a y here, a minus 4, a minus 4. So I've got negative 2x and then y minus 4 times y minus 4. Sometimes your teacher may want you to rewrite this as a y minus 4 squared, since it's that same thing repeating. And that is pretty much it for section 8.6. It's just a bunch of just practicing different factoring techniques. I can do maybe one more just to show you one more example. Let's see. Say I have 7x to the 5th plus 21x to the 4th, and that's minus 28x cubed. So looking here, I can divide by a 7, and I can divide all of these by an x cubed. So I take a 7x cubed out. X squared is what's left in there. This one is just a 3x. And this one is a minus 4. And the x cubed is totally gone. Then I'm going to take a look at this. And I'm going to see, are there any numbers that multiply to be negative 4 and add to be 3? So 1 and 4, if my 1 is negative and my 4 is positive. So 7x cubed, and then that will break down to be x, and we have a minus 1 and a plus 4. And now this is completely factored.